Oh, hi guys, Mr. Bennett here. Today we're going to look at some examples of where you need to use your RRF and solving using row operations. So there is a range of examples. Now, generally in the exam, you'll have a question which will ask you to formulate some equations and solve it, and then there'll be a question that will ask you to do row operations. So some examples of some sort of questions that you might get. So for this one here from the 2004 exam, we have a question which shows you a road network. Alright, so you've got to use your road network here to come up with some equations. Now, what it's saying is the flow into the road network here, these various points, is actually equal to the flow out of the road network. So in other words, I would say something like A plus x1 would be equal to x2, right? And then I'd have something like E plus, so E going in is equal to D going out, x1 going out, and x3 going out. So I need to use these nodes in order to come up with equations. Now, essentially what they will do is they'll give you maybe an answer or an idea about what they want you to do. So here they've given you an example. And then the next thing over here is they're saying, by considering PQR, show that the system of linear equations can be represented by that. So if you couldn't do the first bit, that's what your answer needs to be that you're actually working from to do the rest of the question. Alright, so you get the idea about the way they do that. Let's go to another exam. This is from the 2006 exam. And what they were doing here is they were using the idea of a magic square. Alright, so the sum of the numbers in each row diagonal column have to be equal. So again, it's open-ended in the sense that you could pick any of these things here to come up with three equations. Alright, so this would be certainly one that I would make sure I could do in order to come up with that. And there's no right or wrong way of doing that. But you know, the idea is that you are equating to get three equations with three unknowns in it, and then you can use your row operations to do the answer for that. Alternative for that would be from the 2012 exam, is we're looking at a breakfast menu. Okay, so the full breakfast menu has different options for what you can get, and then it's got the price, how much you pay for each of these options. Okay, from that you need to try and work out how much the components actually cost, how much they're charging you for a piece of toast or a bit of bacon or an egg. Right, so here you've got 1, 2, 3, 4 equations. You need 4 equations because you've got 4 unknowns: eggs, bacon, tomato and toast. Alright, get the idea? So there's an example, very typical example of one where you have to come up with your own equation and solve it. Alright, let's go to another exam. 2010 exam, they have this thing called a trisum, and again it's a bit like the magic square. So, and they've given you an example, so you say x plus y equals 143. So in other words, I could say something like z plus x equals 117, y plus z equals 166. And those are my three equations that I would need to solve using information. Alright, so again, you know, you'd be expecting something like this. Let's go to another example. This one here is quite a good one. This is an experiment you might have done in junior science where you have a rod of metal and then you might mark along their different positions. So A, B, C, D and E. We know that at E it's 100 degrees. Here at A it's 0 degrees, and so what's going to happen is the heat will conduct along the thing, so that might be 75 degrees, 50 degrees, 25 degrees, if this is the example. But they've given you an example of how to actually put that together. So here's an example. They're labelling the points A, B, C, D. Right? And then it says, show that the following equation can be determined by considering a constant temperature at D. Okay, so constant temperature at D. So what's the information that you've got there? The constant temperature at points B, C and D can be found by using the fact that the constant temperature of each point is equal to the average of the temperatures of the two neighbouring points. Right, so It's telling you what to do there. So what we'd be saying is the temperature at say B is X. That would be so let X, Y, and Z represent the temperatures of B, C, and D. So we're giving you that idea there. So if I was looking at the temperature of D, right, then I know that's going to be equal to 100 degrees plus that one there, which was Y, okay, and the temperature that we want is Z. So Z is equal to the Y plus 100 divided by 2, and so therefore you're just rearranging that equation to get Y plus 2Z equals 100. Alright, get the idea? So you have to use information to come up with 3 equations, and then again you can use your RRF to actually solve them. So very typical question from an exam. There are lots of interesting examples, so as I would suggest in your preparation for the test is make sure that you've had a go at a number of different types of exam questions. In a previous video we did an example of using an equation, alright, so that's another one that you might do. Don't think that we have to restrict you to 3x3 systems. We could do this for a 5x5 or a 6x6 just as equally as we can for a 3x3. The reason being is you're using your calculator to solve it, so there shouldn't be any dramas with having more unknowns with more equations. Alright, so good luck with those. Make sure you go through your past exam papers to have a look at the typical examples for these.